Hello. How's everybody? Should we turn this light down a little bit? Hey, Commander. How's it going? Oh, that's as low as this light goes, apparently. Is it? Where's that? There we go. A little better. All right, let's get in just right into day 13. Right in. Welcome back to the stream. Today we are doing day 13 of Advent of Code. So we've been doing Advent of Code every day now for almost 2 weeks. 2 weeks tomorrow. It's a lot. It's a lot of code. It's a lot of Rust. Today's was chill for you? That's dope. I'm excited for a chill day. I'm excited for a chill problem today. Let's just get rid of. Well, let me look at what the problem actually is. Oh, that is my AWS console. Let's just you didn't see that. Don't worry about it. Transparent origami. There's one small mathy snafu though. Snafu? Snap. I thought there was a. We're reaching caves now, apparently. Submarine is equipped with a thermal camera, but when we activate it, we are greeted with congratulations on your purchase. To activate the infrared thermal imaging camera system, please enter the code found on page 1 of the manual. So nobody's ever used it. We've got a large sheet of transparent paper that is marked with random dots. I'm assuming this is grid paper because otherwise I can't think about how this would work. Are we folding this piece of paper? Fold along 7, x equals 5. So let's grab the test input. Let's throw the test input in here. That, I didn't click the right keys to copy that. I've been doing that a lot as I switch back and forth between computers lately, where I'll do Control C instead of Command C or whatever. I need to make those keys the same key on both computers. The first section is a list of dots on the transparent paper. 0, 0 is top left. First value x increases to the right. Second value y increases downward. So the coordinate 3, 0 is to the right of 0, 0. And the coordinate 0, 7 is below 0, 0. The coordinates in this example form the following pattern where hash is a dot on the paper and dot is an empty, unmarked position. Are we going to have to produce this later? There's a list of fold instructions. Each instruction indicates a line on the transparent paper and wants you to fold the paper. Up for horizontal or left for vertical lines. So we only go up when we only go left. In this example, the first fold instruction is fold along y is 7, which designates the line formed by all the positions where y is 7, and we fold left. No, we fold horizontally. Y is vertical. Which is, that looks like halfway. Are they all going to be halfway? Because there's a horizontal line, folding the bottom half up, some of the dots might end up overlapping after the fold is complete, but the dots will never appear exactly on a folded line. Okay, so wherever we fold, we don't have to worry about there being like dots there. Result of doing the fold is basically like taking a matrix, flipping it upside down, and then doing a union, I think. That sounds right? So like we've got the top half, we've got the bottom half. We only flip up, so we only have to like vertically flip. I bet you NDRA has a way to do that. And then we union the two based on the dots. So maybe we do Yeah. Okay. So we just have like some or none. Now only 17 dots are visible. Notice, for example, the 2 dots in the bottom left corner before the transparent. Blah, 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 blah. Basically, if a dot lands on a dot, then it's a dot. Also notice some dots can end up overlapping. In this case, the dots merge together and become a single dot. The second fold instruction is fold along x equals 5, which does like the same thing. So we flip this way and then try the same thing. That made a square. My guess is that that is the number 0. Can anybody guess what part 2 is going to be? The transparent paper is pretty big, so for now, focus on just completing the first fold. After the first fold in the example, 17 dots are visible. Dots that end up overlapping after the fold is completed count as a single dot. How many dots are visible after completing just the first fold instruction? So, okay, cool. So I think we're going to do ND array. I guess we could do like dots as well in a whatchamacallit, dots and a hash map. Then we would just have to iterate and detect which ones are lower than y and do like what would it be? It would be the number minus the y, or y minus the number, and then the fold number minus the y value that's left over. And then we would end up with the proper y index. The method I just described is what you did? Okay, cool. So that works. Parser! 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 I'm imagining like SpongeBob yelling that or something. Maybe Patrick. I think you pretty much nailed part 2 almost. Oh, so it is like figure out what number it is and then print it out or whatever. Okay. Interesting. I want to take a look. So doing it in the hash map is fine and everything. Like it'll work. It's just a bit of math. I bet you this wouldn't be called fold if we were going to look for it in ND array. But I am really interested in potentially doing it with ND array. I'm going to spend like 5 minutes looking for like one of two functions, right? I'm either going to spend time looking for if there is some kind of like fold up function, which probably not. And the second thing I'm going to look for is there a way to, I guess we could slice, right? Because we could slice one and slice another. And then if we can flip the whole thing, then we can just overlay them on top of each other. So we would at that point need the flip function, and also, let me write this down because otherwise I am actually going to forget what I'm even looking for. So either some kind of like fold function or vertical, or is flip and like zip or union. I know there's a zip like thing in here that can let you take like 2 slices of 2 matrices and like build a new one. So we could potentially do that. The hash map approach is probably more space efficient, but I would be curious. So if this works, if we find something here that works, and I do it with the ND array, probably what I'll do off stream is go do the hash map version. Actually, I should ask y'all. Oh, also, hey Jacob, do y'all want me to do the hash map version, or Do y'all want to try to see if we can do this with ND array or something? I feel like the hash map version is useful if you're just learning Rust. Concatenate arrays, parallelized array zip macro, stack arrays along the new axes, linear algebra stuff. Are we doing linear algebra stuff? No. Matrix multiplication, matrix vector multiplication. I don't think that it's not multiplication, is it? The zip has a problem with doubles. These are not doubled. The double does not count. You're saying the doubles don't count? Did I miss that? Like if there's a hash on top of a hash? Yada, yada, yada. They just merge, right? Like that's still a dot. I don't know what you mean by doubles. Yeah, and notice some dots can be overlapping. In this case, the dots can merge together to become a single dot. That's what I expected. If there is almost a hole, then is keeped. There's almost a hole, then is keeped. Zip probably works on a fold, create two iterators, the two parts, and the final iterator has a mark if any of the two iterators have a mark. Yeah. So zip would work. Producers, iterables. I'm looking for something that'll just like flip the axes or something. Let's go. Is this the root documentation? It is. Eigenvalue computation? I don't think we're doing that today. We can take a look at that, see if it's in there. Rand and algebra, image, share, doc, iter, stacks arrays along the axis, enums, traits. What do we have here? I did the hash map thing, so let us do the zip thing. Yeah, if we can find the functions to do the zip thing, I will do the zip thing. Like I said, we need to find the function that will flip a matrix, and because we already have slice, right? So we can already take two slices looking at the same matrix. And then we do have zip, right? So zip for us will let us take two matrices, or matrices, whatever. And basically gives us a producer of them. So we should be able to, if we can take two slices, do a zip with both of these, and then for each of them basically be like, ah, yes, this is the new one. I assume that zip lets us create a new one. Yeah, map collect to create a new array. So zip from rows, map collect row.sum. So this one in particular is just creating a row of values, so it's compressing, but I think we should be able to do something like that. Can we do like a reverse slice maybe? Maybe we do an array view or a slice. Where's our slice stuff? Slice. This is the slice argument constructor. It would be nice if there was just like a flip. Should I just search for flip before we do this? Azip. Fold is never going to be what we want. Fold is going to be the programming version of fold. Fold along an axis. What is F? Where's F? FN mute PA. That looks like a regular fold, just along a specific axis. There's map axis, par fold. Probably is rotate. Is rotate good enough? I don't think rotate is good enough, is it? That fold method is not actually what we want anyway. It's going to be fold, but it's going to be fold for a specific axis, so it'll fold the rows individually, so we'll end up with the columns number of rows or whatever. There's axes. Did I open the S? I didn't open the S docs. Deref into view, diag, dim, dimensions, dot. What is I? First fold. Fold axis. Fold axis is not what we want, but I'll open the docs just to check. Gen rows, get, index. Indexed iter is going to be all of them. Like when it comes down to it, we could just do the 2D arrays, indexed iter, and build up a new one. Into raw vec, into shape, into slice, invert axes. Is that what we want? Reverses the stride of axes. I don't know what a stride is. Stride, axes. A single stride along the axis must land you in the same place as taking n many strides of length s. So stride is like a directional. I think invert axes is what we want. So if we can get the slice and then we can invert the axes, then the only thing that we need left is to merge one into another. There's got to be some kind of merge function, right? Not merge axes. Union. It's probably going to be zip. I don't see how it would be anything else. So let's do zip. I think azip is the thing that we're supposed to use. Create a new array with one entry per row of A. Use azip to traverse the rows of A and assign to the corresponding entry in totals with the sum across each row. It bothers me that this is a macro. I don't love that that's a macro. I would prefer to use something like this, maybe. So I think we can do this. I think we have enough stuff to figure this out. So let's do the parser. The parser is going to be a set of input and then a set of folds. So we'll go with leave this open like this, and then how do I open a second pane? There we go. Then over here we can do lib. This goes all the way over because we don't really care that much about it. Am I blocking that? No, I'm not. Okay. Puzzle input. I'm just gonna get rid of all of this stuff, the B-tree maps. The step we don't need because we're not recursing anymore. Just removing yesterday's stuff. And then what's the thing that we have to get at the end here? How many dots are visible after completing just the first fold instruction? So 17 for the first one. Then we'll comment this out. Step doesn't exist. Okay, so we've got the puzzle input. I feel like I should go grab the code that we did on day whatever. What's the other day? Advent of code. It is kind of nice that the problems repeat, because if you put a bunch of work into doing like the parsing or something for one of the other days, you can reuse it across the days. In lib here, I think we do the ND array stuff. Into cars, puzzle input, vec, cloned, option, shape vec. So this is effectively what we need. And all it's doing is this is doing a separated list, but we're not going to do a separated list. We're going to do something slightly different. This is actually not going to be this parser. This parser is going to be fn dots input string slice. We're going to return the I result because we have to return the I result. Well, we don't. Okay. Because it makes the most sense to return the I result. This is going to return an array too, if I can remember correctly. Probably what no. This is going to be a custom enum. We're just going to call this mark. And then this is going to be a separated list by new lines, and it's going to grab pairs, separated pair, if I can type, separated pair 1, digit 1, no, we'll do U8, and then I should check to see if this is U8s. We'll do U8, and then we'll do comma is the other one, tag comma, and then U8. I was thinking about the input in my mind, and the input is right here. I don't know what I was doing. Okay, so we got a separated pair, which is going to be 6, 10, whatever. I'm going to take a look at the input to make sure it doesn't get bigger than a U8. It does. So we're going to do, we're just going to do U32s for now. We're not going to think about it. We're just going to do that. Happy Monday. Hello, Xander. Nice to see you. You know, mark is either going to be marked or unmarked. And yes, we could use an option for this. But if as it turns out, if you use an option for this, basically what you're doing is just storing arbitrary useless data, because the option needs to hold some value, right? So in this case, we don't actually have a value. We just have whether it's marked or not. And doubly, as it turns out, if we did this, like did U8 or something, this is exactly the definition of option, actually. So we have mark, and then this would be some, and this would be none, and we could use it in the exact same way. So it's not like the Rust language has anything like over you. When it comes to building up your enums and stuff. I think those aren't in there, are they? Where's nom U32 character complete U32? Yeah, that should work. What's wrong? Expected result found enum. Yes, I'm doing this in a very tiny window over here. A bunch of flattened stuff that we don't care about. Length for tuples that we don't care about. Nom character complete U32. Nom character complete whatever. U32. And then we just get rid of this. So we have to remember, if we ever want to do a function off of a U32, like an associated function or something, we have to explicitly use the path to it, the module path. Okay, so we get separated pairs, we get separated list, we get a separated list of separated pairs. This needs to go until what? This needs to go until there's a new line. Let input whatever equals I could just do 2 new lines here, right? I think that's what we're gonna do. New line, new line. Actually, this needs to go somewhere else. This needs to go in the other thing. Because this will be puzzle input. This will be let input dots equals dots input with the question mark, and then this will be new line, and then let input folds equals folds input. And these need to be error handled, and this needs to be okay input dots. I guess we'll do dots fold. Parsed dots, parsed folds, and we'll just update these to be parsed and parsed. Parsed dots, parsed folds. Folds isn't a function that exists that we need to create. So input or fn folds, input string slice again, because that's our input. I result type, because that's our return type, which takes a string slice and returns a, what are we going to return here? We could do like capital F fold, and then up here, we'll do it right above folds just to keep it local. Enum fold, and it's either Y and a U32 or X and a U32, right? And this is going to be let folds equals, or not folds, let input f's equal separated list 1 new line. I guess we can call this fold. We should do this down here then, right? If we're going to do it like that, we could do it here. Parsed folds. And then this handles the input. And then this is just a single fold up here. And that means that let input f equals, no, this is not f, this is tag fold along space. Just doing a little bit of cheaty. Let let's see, input axis num equals separated r8ed pair, and this is going to be car, and this is going to be tag equals, and this is going to be U32. All right. This is the car. The car needs to match car. We're either Y, in which case we are Y. And if we are X, then we are fold X. num. I think that's good enough, right? And this needs to be like, we're never going to have this, but if we get anything else, then we just panic. Not X or Y or fold. This needs to be complete car, I think. Right? Because up here we have complete as self, and then this needs to be car, right? Did I type that wrong? Complete car. Nope, we got it. So what's the problem, dog? A bunch of errors that we don't care about because we haven't fixed the bottom of the program yet. Oh, complete is already in here? Why is complete already in here? Because complete is bytes. We aren't using that though, so we'll just chill on that. So what we've got here is complete car, tag, separated pair. Yo, dog, I heard you like errors. Does it have mirror? Oh, I didn't catch that earlier, Nikki. I don't know if it has mirror. Let's find out. No mirror. We also didn't check this other crate that apparently has a bunch of other more advanced things. Mirror, flip, a lot of skips and vips. So, doesn't look like it. And we don't really have like systems and stuff. Transpose, because transpose give us a way to, what is a Hermite transpose? Is there a way to get the code afterwards? What do you mean by the code? I'm doing too many things too quick for you. I can slow down. When I'm done fixing this, I will explain all it is. But yes, there is a place to get the code. I'm happy to slow down. I do not need to go as fast as I'm going. I'm basically like, this is the way that I program when I'm regularly programming. It's basically like, it's non-linear, basically, which makes it really hard to follow on stream. So like, if I'm doing stuff in a weird order, just let me know and I'm happy to go back. I'm happy to linearize it. I'm happy to slow down for a second. Or if I can't do that, I'm happy to go back after we've written the code and explain exactly what we did. So yeah, Christopher Biscardi, github.com, Advent of Code repo has everything for this year. Okay, let me get rid of this other thing so I can make the errors a little bit bigger. Okay, so puzzle input doesn't return a B-tree map, right? Our puzzle input returns a tuple of an array 2 that is a mark and a vec of folds. So that should get rid of some of the errors here for us. Expected tuple found enum fold. Result string. Why are we expecting a tuple there? That's interesting. Oh, why am I matching on complete car? I need to match on the axis. What a What a blunder. One of the classic blunders. Only slightly less famous than getting into a land war in Asia. Oh, you know what I did? I know what I did. So let's do this. Let's do tag equals sign, and then instead of car here, well, it should be car needs to take a specific like match, right? Like car is looking for a very specific where's Nam? Nam is over here somewhere. So car is not what we want. Car is an exact match. What we want is any car. I was using the wrong parser, basically. So this will be any car, and that'll fix our type errors here as soon as we import it. And then fold here. Oh, right, because this needs to be input. And then this is a tuple. Okay, that's a bunch of stuff. So we're back in dots, and dots gave us a separated list of a bunch of pairs, which we're going to need to map over to transform. We should probably do that immediately. So well, outputs.length. So, okay, so if we do the ND array stuff, we have to now produce a full ND array, right? So we need to find the max values for A and B. So that we can get these lengths, right? Is there, because what we have now is X and Y points, right? The input that we have is in this test input is basically like XY, 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 XY. So maybe what we do here is we find the maximum values for the X and the maximum values for Y. And then we construct a array 2 from a preset set of arrays, and instead of doing the whole thing, we construct it via those arrays, and we mutate on those arrays through indexed mute. That seems like the right move. So let's do let max x equals outputs.iter.max by AB A.0 B.0. Max by, and these are ones now. And then let's get rid of this for a second and stick a to-do in here, and we'll take a break from just charging through this, and I'll explain what's going on here. Okay. So let me run cargo test. Make sure that that runs. It'll panic, but make sure it runs. And then let me add a couple debug statements in here to make it a little easier to show. Let's do debug max x and max y. And then we'll debug I guess we could debug dots here. It won't be that big as well. Or not dots, but outputs. And then in our other parser for fold, which we aren't going to get here, so we'll do that in a second. So when we run cargo test, what we end up with from this parser is basically a vec of pairs where the first value in the tuple is the x value and the second value is the y value, right? So we get that whole list. And then what we do here is get the maximum x and the maximum y, which we're going to use to, not big, have a look at the real puzzle input. Yes. Not big in the sense of I'm about to explain the code and thus I can scan through it right here on the terminal without having to go 50 million lines because we're using the test input. Remember, we're not looking at the real input. So we have process part one, right? Process part one is just calling puzzle input. It's not doing anything right now. Puzzle input is our parser, right? It's a nom parser. It takes a string slice as the input and returns whatever we want it to return. In this case, we're returning a tuple with an array 2, so our matrix of whether the cells are marked or not, and a vec of the fold operations that we actually need to execute. Because if you remember our test input, it's got all of the dots up here, which is going to comprise our matrix. And down here, we have our fold instructions, which are fold like Y7, fold X5. So what we end up with is a matrix and a vec. The first thing we do is parse out the dots. We built our own parser for this. And then we did 2 new lines because the folds are separated by 2 new lines. And then we do a bunch of fold parsing. So we're going to ignore the fold parser for a second, and we're going to go straight to the dots parser. The dots parser, we are going to take a separated list. So again, the values that we have in the test input are digit, comma, digit, right? And then a new line. So if we do a separated list here for new lines, then we get basically all of the rows that have all of the digits and such. And we use separated pair to do a digit on the left, separated by a comma, and then a digit on the right. And that's how we get this giant list of tuples, right? So this giant list of X and Y positions, which will be even bigger for the real input, that's how we parse that out. So the next thing that I need to do is construct the matrix that we're going to use to actually do the transformations and stuff. So to do that, I need to get the maximum X value and the maximum Y value to be able to size like the vec that we're going to create here to create the matrix. So this one's going to be .0 and this one's going to be .1. I'm going to unwrap both of them because they have to work. If they don't work, then, you know, it doesn't look good for us. So we've got n rows and n columns. X is columns. So this is just going to be max X. I'm just going to rename them here for clarity. I don't actually need to rename them here. And then I'm going to uncomment this and uncomment this. And what we're going to do is create basically all of the vecs that we need. In this case, this is going to be mark, unmarked, And this is doing the padding thing from the other day, so we actually don't need to do this. We do need this in like a number of times. Let's see what error we're getting here. Trait clone is not implemented. Okay, so we can do that easily. I'm going to derive a couple traits here. Derive. We're going to do debug because I'm going to debug stuff later. We're going to derive clone. And I think that won't be enough, but we'll continue with that for now. Expected U size. So we have a U32 here. We can just make this a U size because we're doing a smaller number into a bigger container, so we don't have to worry about it. Dimension is not implemented for U32, U32. Because n rows and such as are, let's do, we could do it up here, but what I'm going to do is as U size when we use them. I'm going to do this at the site that we actually need them to be U sizes. The other option is to weed that all the way back through the beginning and actually parse out U sizes instead of U32s. So what we have here is a single vec of one row size worth of data. We actually need this times the number of rows, right? So actually here we can do n rows times n calls. As U size. And now we have what I believe is a vec that is long enough, but it is not. Why is it not long enough? Did I mess up the lengths? Oh, I don't need to add 2 here. That's what I did wrong. Adding 2 there was specifically for the padding that we were doing in day 9, because I copied that code from day 9. And this needs to be n rows times n calls, because otherwise we don't get the number in total. So what we've done here is we've created one very long vec that represents all of the data that would be in our matrix. And we did this because what we need here for array2 from shapevec is one really long vec, not a vec of vecs. So that's why we created one really long vec with the default values instead of doing something else. So we assume that worked, which means that we can now do r.indexed iter mute on the array, right? Actually, we don't need to do that, do we? We can do, let's iter over the outputs. So outputs.iter for x, y, right? In outputs.iter, we're going to do r.get mute x, y. I'm going to call this point. And we'll see what's wrong here. These are references, which is the problem. So we'll dereference them. Was that actually not the problem? The trait ND index is not implemented for U32, U32. What did I do wrong here? Oh, these need to be usizes. So I probably should have parsed these into usizes because we're using them as indexes so much. It would have made it a little bit easier to work with, but it's really not also not a problem. Rust compiler is telling us that we do need ARR, so our matrix to be, we'll make this dots. Let's do dots. Our matrix our dot matrix needs to be mutable, because when we do get mute here, we need to actually reach into references inside of the array, right? Or the vec. So the Rust compiler is basically being like, hey, you know, you need to say that this is mutable, or you won't be able to get it as mute. So if we get this point, right, this point has to exist. So let's unwrap it. And then point equals marked, marky mark, and the funky bunch. So we should be able to set the data at that point. I called option unwrap on a none value. Interesting. Dots get mute. So let's debug here. So it's setting that I'm doing an out of bounds index, right? Basically, I'm reaching into this matrix and I'm saying, get me 610, and there is no 610. So let's go back up here and let's say debug max X and max Y. And I wonder if we're just chopping this off incorrectly. So 610 should exist. Why is that none? Did I mess up? Mark unmarked. Pros calls. Let's debug data. This will be like a 10 by 14. Oop, I need to debug a reference to data. This will be a 10 by 14, basically, well, it won't be 10 by 14. It'll be 140 unmarked. All right, see, we've got 140. So we've got 10 items this way and 14 items this way. And we're looking for the one at 610. And the one at 610 in the array, in the matrix itself, for some reason is a none value. Why is it a none value? It's interesting, right? Why would why would 110 be none? What did I mess up? We've messed something up in the construction of the matrix, is basically what I'm reading out here. Because if we debug dots here, we'll debug a shared reference to dots so that we can do it. If we debug dots, we do get what looks to be let's do, I really want that to be X's and dots, but I'll do that later. It looks like we have 1 2 3 4 5 6 7 8 9 10. So we do have 10 values, and it is a matrix of all of these, right? The shape is 1410. So 14 rows, 10 columns. Is that right? Actually, let's take a look at the test input. Test input says, yeah, 10 columns, 14 rows. Yes. Yes, yes, yes. I've done something wrong here. Because we shouldn't be getting none for these. We should be getting unmarked. You think it should be +1? Five, 6, 7, 8, 9, 1, 2, 3. Is it giving us... I thought it was giving us 0 offset stuff. Because 0, 0 is the point up here, and they were pretty clear about that. Which means that 0, 9... Oh, yes. We do need to +1. You're absolutely right. Because those are indexes and whatnot. So that kind of solves our problem. Did I misalign? Did I mislabel the rows and the columns again? I would not be surprised at all. I've done this before. Easily done this before. Okay, so that's giving us sum for all of the points. And we did fix a bug. Thank you, Commander. That would have been a nasty one. Okay, so we've got our array. We're getting our mute. We can now do this, and we can now unwrap. So now we have our matrix of marks. So what we get back from all of this, after we're done with dots, so we just returned our matrix, right? Which means that this first line in our parsing has succeeded. We then have to do 2 new lines because there's 2 new lines of space between the dots and the parsed folds. The parsed folds are separated by a new line themselves, so it's fold, new line, fold. And that gives us the fold parser. The fold parser is looking for the tag fold along, because if we look at the data, everything says fold along. And then we have a character, an equal sign, and a digit. So we do a separated pair because we're looking for any character. We're basically looking for X or Y, but we can do any character here. And then we have an equal sign, and then we're parsing a U32 out. And what we've done here is we've used an enum to encapsulate whether we're doing a transformation on Y or a transformation on X. And because enums in Rust allow us to store data, we can just store the U32 in here. And later when we need to operate on it, we just know that that's going to be Y-axis with that specific number. This is called a module path. So you'll see that when we do imports up at the top, we use like nom, character, complete, any car to bring any car into scope. Items like enums also participate in this module path. So we could continue that and pull in just the Y variant of an enum. Because the enum is defined in this module, we already have fold in scope, but we still don't have Y in scope because it's inside of fold. So we need to use : here. Okay, so we have our matrix, we have our folds, and then this is not allowed ways. This is going to be dots and folds. Let's do let mute folds dot iter. Let's do let op operation equals folds dot next. dot unwrap because it needs to exist. Let me it equals folds. Okay. So basically what we're doing here is folds is a vec, right? So we iterate over the vec and we create a basically a mutable reference to that iterator so that we can call this next function. Iterators, when it comes down to it, are just structs that have an associated function called next that you can call on them. So in this case, calling .next just pops the next one off the vec and hands it to us. So we unwrap because that should always be there. And if it isn't there, then we parsed something wrong. So we can match operation here. And this will fill in the match arm. So Rust Analyzer fills this in for us. I think this is column and row. Hopefully. So we've got a Y fold and an X fold. We only really need to implement the Y fold because the first operation is a Y fold. So let's take a look at that. And then I believe that what we do here is probably we're probably going to do like do fold, and we're probably going to pass the matrix in. But the matrix isn't going to be mutable because we're not going to change anything. We're going to construct a new one. So do fold or do Y fold or something. We're going to call this do Y fold for a moment. Dots. We can do it. We'll just do it right here for the second. I'm not even going to abstract it yet until we've written it. So what we need to do, I need water. What we need to do now is slice this matrix at both of the points. So we have the middle row, right? Let's look at the visuals here. What we have here is the middle row. And we're not going to use the middle row. We're going to take a slice from here to here, and we're going to take a slice from here to here and get two matrices out of this. So we should be able to S, which is an ND array slice macro, and do 0 dot dot dots dot length. What is length going to give us on this matrix? Right? Because I'm not sure what that will be. 165. So it gives us the length, the total length, which is not what we want. We want like row length or call length or something like that. So let's figure out which function to call. So this has a bunch of stuff like columns and columns mute and this is total number, returns the length of axis. Okay. And axis is what? An axis of a U size. So we can do length of axis 0. Right? And then S 0 dot dot length of axis 1 dots dot length of axis 1 but matrix A equals this, but the second row reversed. Beginning by 0 to first slice 0 to row without the row itself. This is not like it's a two-dimensional slice operation. It is not a slice function, if that makes sense. Let's do these numbers first. Let's comment this out. Debug row index test row index 7. That's not what I wanted. I wanted num rows, num calls. I guess it could happen anywhere, but realistically, as far as I can tell, it will only happen at the halfway point. Right? Like, I think that this isn't pathological in the sense that the folds always happen halfway down. So, or halfway across. I don't think that we're going to end up with folds that are like smaller pieces of paper, but we can figure that out later if we do. Did I debug this out yet? 11 and 15. I'm trying to do something for part 2 and just realized I was debugging the wrong thing. Major dope moment. Yep, I feel that. Okay, so num calls equals this over 2. Because that'll give us the halfway. Right, so we get 7 debugging prod energy. So the matrix here is going to be 0 to num rows, and did I put s in here again? That was weird. 0 dot dot num calls. So theoretically, this should be a 7 by 11 matrix. Then we're going to do the same exact thing here, and we're going to do row index plus 1. So if we start at 0, we go 0, 1, 2, 3, 4, 5, 6. And then I think we do plus 1 because we want to skip that one, right? That's not going to compile for some reason. I'm just going to comment it out for a second and check the other one. Okay, slice info, start 0, end 11. Start 0, end 7, step 1. Interesting. Can we do this instead? Matrix a dot iter So interesting that it only gives us 2 rows. Let's take a look at the slice documentation for a second. I had it up somewhere, didn't I? This is the thing that we needed to look at. Okay, so this gives us a slice. A slice has a start and end and a step. Did we want an array view and not a slice? From format hash slice. Let's look at the slicing section of the documentation for a second. You can use slicing to create a view of a subset of the data in the array. Slicing methods include slice, slice mute, slice move, and slice collapse. The slicing argument can be passed to the macro. Yep. The explicit form. If the range is used, the axis is preserved. If an index is used, that index is selected and the axis is removed. This selects a subview. So I don't think we want subviews because we want the axes. So in this case, S with some ranges gives us, I guess we could R2 it. Slice ded.shape. Two disjoint mutable slices of a matrix with one containing all the even odd indexes and one containing all the odd index columns. Why would you do that? I'm sure somebody has a reason to do it. What I'm trying to avoid is I'm trying to avoid reconstructing the array too. And also I want to make sure that what I did was correct. Matrix A.iter. Index iter doesn't exist on slice. Into iter, get unchecked, concat to owned, align to mute, array chunks as chunks. Fill, get, sort last, partition, rotate. There's rotate functions here on the slice. Rotate doesn't work for us though, right? We still have to flip. Is that reverse? Is that reverse? Is reverse what we want? Swap, slip, Windows, zip. So it's not gonna give us a good debug output here until we do something with it, is it? That kind of stinks. What if we intuit her? Does that change what we get? No, we still get the debug output. That it doesn't exist on Slice. VS Code is lying to me about what methods I have available, isn't it? Yes, the index for the second part needs to be reversed. We're not even there yet, because I can't print out a view of the matrix from this slice. So we have the slice. I know we have the slice, but there doesn't seem to be a good way to like prove that we have the slice that we want right now. Maybe we do dot shape. Right. If we do dot shape, shape should give us like the X and the Y coordinates, but shape doesn't exist. A dot shape. A is the array. Don't they use shape all over the place? A slice. Oh, you know what? I did. I don't think I... Okay, so that was literally just a slice that we were working with. That's why it wasn't working. Because it was a slice struct. It was not the matrix with the slice applied. You know, some days the brain just doesn't start. So if we slice like this, we end up with all of the X's, some of the Y's, exactly what we wanted. Let's do the same thing here. And remember to apply dots. So there's a slice function on the matrix, and that slice function takes the output of the slice, I guess, struct constructor macro. So shrug. Expected U32 found U size for num calls. Why did we expect a U32 for num calls? Is it because we're globbing onto row index? Trait from range U32 is not implemented for slice. We should bring up our Rust analyzer trusty stuff here. I think this is it. So we just need row index to be a U size there. So we end up with the two matrices. It does look like matrix B is empty. Shape 11-0. Oh, that's not what that is. Ah, whoops. We need the total value. Okay, so now we have And I'll explain this in a second because that was me being confused. 1, 2, 3, 5, 6, 7. Now we are 7 wide, which is not what we want actually. So that's not X and Y, that's rows and columns. This will forever confuse me. I think that rows. Nope, that's even worse. 7 and 3. Yikes. Calls in slice. Axis 1 dots length of calls over 2. Those look fine, those look fine. Num calls in slice. So num calls in slice, num calls in slice. So this needs to be the number of columns, and that needs to be the number of rows. I guess we'll do num rows in slice as well. That doesn't seem right, does it? This is just me being confused as to which place I need to put the columns in for the slice, because ND array works differently than my brain works. 2, 3, 4, 5, 6, 7 wide. That is not what we want. And we are, what, 7 by 7 there? So let's ditch matrix B for a second and let's just do matrix A. I'll debug matrix A. And this should be the simple version where we get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 wide. 1, 2, 3, 4, 5, 6, 7 deep. So that's the correct, like, width and height. Humans do XY, computers do YX. I don't know. I don't know that I agree with that entirely, but it's definitely the case in this this situation. I don't even know that these are labeled correctly anymore. So num calls and slice. And num rows and slice. The num calls and slice is the 7. So that's where we need to do the +1 stuff. So this goes here with the calls, and this does that's not accurate. Those names are wrong. Why is the stride 15? Row index should be 7. So 7 plus 1 calls. So 7 to 15. And then 0 to num rows. Num rows should be Num rows in slice 11. That is not the number of rows. That's the number of columns. I fucked up. Okay, that's the number of columns. So 0.11 for both of them. That seems right. Which means that this range is probably what's wrong. That range is 8 to 15, which seems right. But it's telling me that 15 is past the end of axis of length 11, so maybe I did mess this up again, and I just got lucky on the first one, and this is supposed to be below this. And now we're getting an assertion failed, but we're getting 1, 2, 3, 4, 5, 6, 7. What is wrong here? I'm getting 11 vertically and 7 horizontally, right? And that's for matrix B. My brain hurts. Matrix stuff is rough. Check matrix A again. This is 1, 2, 3, 4, 5, 6, 7. So this is also 7. So I did have them in the right direction earlier. Because we want 11 items inside. But if we do it this way, it panics because slice end 15 is past the end of axis of length 11. So if we have Y7, the line counted beginning at 0 is ignored. So the first from 0 to 6 and the second one from max to 8. Right. But we can't do negative ranges. So we have to go from 8 to 15. Right, because calls is 15. You're saying 8 included, like, when we start at 8, 8's included. Right, like a range from 0 to 5 does 0, 1, 2, 3, 4, 5. If we have a 2 by this is 3 arrays. Yikes. This is 2 submatrices. Why do they have to be so confusing? Only the first row in each submatrix, 0 to 1. So this is everything. Oh, can we just do dot dot? Is that going to be easier for a bunch of these? That's interesting. Okay, another way, Y7 matrix A equals from 0 to 6, matrix B equals from 8 to max, and then reversed? Yes, that's exactly what I'm doing. My problem is not my understanding of the thing that I need to do to the matrix. My problem is understanding the API, the slice API, because what I'm doing is putting the columns in the wrong spot here, and I've named them the wrong things, and etc. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay. So I think it is reversed. Matrix B. Yeah, my issue here is not that I am confused as to which rows to pick. My issue here is that I am actually picking the wrong rows when I give the numbers 1, 2, 3, 4, 5, 6, 7. Why is this a length of 7? I'm so confused. 11. Is this like reversed or something? Did I? Is it like rotating? Okay, slice. We're gonna go with axis 0 length, and this is axis 1 length. And this is num axis 1. And that's what we're going to call it that stuff. So in that case, these things look like they're in the right spots. Right? Axis 0. Axis 0 length is 11. So 0 is x. And 15 is y. So if that's the case, we are doing the right calculation here. And this should work, because this should be everything in the interior, everything on the x, and a subset of the y. But what it gives us is 1, 2, 3, 4, 5, 6, 7 by 11. Why? Let's do this. Let's be... Okay, I'm going to use a debugging technique here that I'm using just because I'm very confused at this point. Let's do mute dots. So all of this stuff, and this is the right, like this is supposed to be an 11 by 15, right? Let's see. This is the thing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So it should be 11 by 15, which is correct. That's what we have. And when we get dots here, is there a map or something that I can do here? The example is x equals 11 by y equals 15. Yes. The problem is that the slice that I'm getting is 11 by 7. Right? Right, like the shape of this is 11 by 7 for A and B. I guess that's technically what we want, but I thought we wanted 7 by 11. So I feel like these are these actually right? And then I'm just 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Did we make it so that the column number 1, so the question I have in my head is, did we make it so that column number 1 is the x-axis by doing the slices? That would be really unfortunate. And to confirm that, I think I can confirm that by doing a quick test here, copying a little bit of code. I'm going to say that we're not using this for a second. And then we do this. And this is what? 11. And this is 15. And this is 0. Print max x and max y. The dots construction seems right. So we do have max x and max y being printed out, I believe. Somewhere. See, like the length of the x-axis is 15, or axis 1, which is y, for some reason, is 15, and the axis for x is 11. Right, so if I briefly go back and I pull dots in again, and I do debug dots, this should be correct. If this isn't correct, I will... Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, that's the issue. I wasn't paying attention when I did this, clearly. I wish the names matched up. So, n calls, n rows. So we think this is n rows, n calls. And then when we get here, do we have to do y, x? So what we end up is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And if we look at the example, we have 1, 2, 3, 4, 7, 10. 4, 7, 10. So 0, 1, 2, 3, which is 4, 5, 6, 7, 8, 9, 10. So that is the way that it should be. And then we go back to the other thing and we fix that now because that is now wrong. So this needs to be flipped. And we end up with a matrix that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 1, 2, 3, 4, 5. 5 is wrong. 1, 2, 3, and 3. 5 and 3 is wrong. So do I do these calculations? Am I doing num axis 1? So 1 is the internal axis now, is what we're saying? So it's not... So these dots are in the right spot, right? Because we are 11 wide. And the vertical is wrong. So the dots are in the right spot. And this needs to be num axis 0. Do it that way. That's matrix B. This is matrix A. A is now 1, 2, 3, 4, 5, 6, 7. Okay. Matrix A is now 7, 11. We've got our Slurpee. And that needs to be axis 0 length. Why did I name these len and length? What was going through my head when I did that? Okay, and now we've got 7. 1, 2, 3, 4, 5, 6, 7. So we've got 7 and 7. We got it. We got there. Yikes. Yikes. We don't use axis 1 length. So now we do matrix B dot axis it wasn't fold axes. What was it? Invert. And this is which axis we are going to invert, which we discovered that 0 is Y. So this needs to be axis 0. And matrix B needs to be mutable. So what we should end up with here, I'm going to make this smaller so that we can read it a little bit. I know it'll make it a little harder to read on stream. So 3 in from the bottom row on matrix B should be marked. Yeah. So the first row should end up being marked, unmarked, marked. Yes. Okay. It worked. We did the thing. And now we need to combine them. So now we're in the zip stuff. There's some map collect function. We should probably be looking for that. This is on zip. So there's map collect. Map and collect the results into a new array, which has the same size as the inputs. If all inputs are C or F order respectively, that is preserved in the output. So potentially we should be able to use map collect. I don't see anything else that looks interesting. Apply collect, map collect. Why am I seeing map collect 3 times in this documentation? I feel like I'm having a oh, because it's an implementation for a bunch of different dimensions. Okay, I got you. So if we go back to the zip and we look at this, it's going to be zip from this. It'll be like zip from matrix A. What do we do here? Do we do iter? Can we just do matrix A and matrix B? Maybe it'll just work. Does it just work? Import zip, end array zip. And name this small matrix map collect. Okay, expected closure that takes 2 arguments because we get A and B. And this can't be row.sum. This is match A, B. Actually, we're just going to call this point. We're going to match point. Match point. Nope, not the return type. And then we're going to do marked. Marked, comma, pipe, mark, marked. And both of these result in a mark, and anything else results in unmarked. Yeah, it does sound like a tongue twister. Oh, it is 2 arguments completely. So it's A, B, not. And what we want to match on the tuple. So I brought the 2 arguments into a tuple to match on them so that we have a singular match to make. And if either of them is marked, then what we end up with is a marked spot. If both of them are unmarked, which is the only other case, I guess, so we can make that explicit. If they're both unmarked, then we get an unmarked. Okay. And what we end up with is hopefully a small matrix. One, two, three, four, five, six. It is a 7-11 matrix. What's the result here? Should be what? 1, 2, 0, 1, 2, 3, 4, 5, 6. Oh, wait, that's not the one. Okay, so 1, 2, 3, 4, 7, 10. 1, 3, 4, 7, 10. 1, 3, 4, 5, 6, 7, 8, 9, 10. So that works. This was an adventure. This was definitely an adventure, but that works. You need to explicitly handle marked. No, I don't. The reason I did handle explicitly marked is that underscore means handle anything else. And when matching on things, I prefer exhaustively matching on things unless I really don't care what else it is, right? If in part 2 here we have like marked, unmarked, and like half marked for some reason, I want to know that I'm not actually handling that here. And the Rust compiler, because I have explicitly marked on, or explicitly matched, the Rust compiler, because I have explicitly matched on the variants of the enum in the combinations that they can apprise in, when I add something to the enum, it will tell me right here on line 113 that I am not matching on the new ones. So that's why I didn't leave it as like everything else, because it's not in everything else, right? It's marked and unmarked. Do the input files contain sensitive data? I could use some more examples to finish my tool code. I don't think they have sensitive data. Is it illogical or this way? I don't know what you mean by is it illogical or this way. You mean, is it like, theoretically we could have, what, like a binary comparison of some kind here? That's not where my head was at, because I don't know, it's not where my head was at. But theoretically, yeah, we could have some kind of binary comparison. The implementation would end up being probably the same. Or similar. So we have the small matrix, right? And the small matrix, what do we actually need to return from part 1? 17. So we need to small matrix dot folds, actually dot map. Actually, that's not what I want either. I know I'm abusing indexed iter here. But it's the easiest way for me to get points right now. Like, I feel like there should be another way to get all of the items. So maybe I'll look for that in a second. But we can do this with index ditter, map, and then sum. And then this, what? Sum is not implemented for unit. We're not returning anything from what? This whole thing? There we go. That's what it needed to be. That needs to be our return value. So now our test pass. I think just plain iter would work here. I don't feel like it would, but we can try it. Yeah. Expected mark found tuple. It does. You're absolutely right. I feel like the other day I was using iter and it was giving me rows and it wasn't giving me the items. So I'm not sure what came of that. Yeah, not sure, but glad it worked. And thanks for the suggestion. So let's get the input and run this. This is also probably going to be much more space than we otherwise probably would have needed because we're constructing the full array. What happened there? Because we're constructing the full matrix and not just the points, we could just construct each of these points in a hash map and it would probably be more space efficient. So while I'm curious about the DAT results later, and maybe I'll try a heap-based approach and see what the difference is. I'm expecting this to take more space, regardless. Unless there's some like really fancy storage stuff that they're doing for the matrices. Okay. Cargo, run, bin part 1. I didn't remove the debugs. Let's get rid of all of these debugs. Okay, they're all gone. Panicked at not yet implemented. You know what? You're mean. Advent of code. You're absolutely mean. The issue here, of course, is that we did the x-axis, but we didn't do the y-axis. So I'm going to copy this. Actually, what I'm going to do is I'm going to, I guess, return the small matrix from this. And then do this. And then here I will grab everything that we did here and I will drop it in here, understanding that the axes need to be different here, right? So this needs to be axis 1 length, right? So this is axis 1 length here, and this is num axis 1, which means that this needs to be on the other side. And I think I could write this in a more generic way. I just don't feel like it right now, to be perfectly honest. And if we get the wrong answer, then we'll fix it. Well, we got the wrong answer. Because I didn't flip this one. Was there a reason you used length of instead of n rows, n calls? Is there n rows, n calls? Partially because the columns and the rows things is just fucking confusing me, Derek. Like the X's and the Y's not matching up between what I'm thinking in my head and what's going into the computer is really tough whenever I work with these matrices. And you can see it on stream when I'm doing this and I'm going through the matrix and I'm like, is this the X or is this the Y? And then I spend 10 minutes doing like figuring that out. So like n rows, n calls doesn't help me because rows and calls with the n rows and n calls isn't what I think of them as being, for whatever reason. I do need to go back and like update this code because that's not the right answer. Your answer is too high. If you're stuck, make sure you're using the full input data. You know what? I really, really, really don't like that they give us different things. Let's do this. Let's do... Do we need to generate everything at any point? We don't. I wish I knew what part 2 was before I make this next step. I didn't want to abstract this before then. But we do have to deal with this. Oh, you know what? I'm inverting the wrong axis here. There we go. I was inverting the wrong axis. I'm really happy I didn't need to go in and debug that and build out a bunch of extra functions and tests and stuff. That would have taken a while. Part 2, finish folding. Finish folding. Okay, cool, great. The manual says the code is always 8 capital letters. What code do you use to activate the infrared thermal imaging camera system? Okay, so let's do, where's process part 1? This is process part 1. Let's get rid of this. Let's just grab all of this bullshit. And let's drop it here. And let's do, this is not going to be sum. This is going to be, I guess, the full matrix, but we'll leave it as sum for a second. You solved the problem I had in my solution. The XY line that flips had to be deleted. Yeah, so we just ignored it in this one, right? Like the matrix approach, if I can get my head around how to use this library, I think the matrix approach actually turns out to be better in a way, in terms of writing the code. I don't know that for advent of code and whatnot that it is actually better than the like hash map version. The hash map version is fine. But in my mind, when I'm thinking about problems like this, the less I have to do like X minus Y, little mathematical operations all over the place to determine indices, the less I have to do that manually, the better. And I think that the matrix approach means that we have to do much less of that. So like we're not iterating over the index of each of these and then calculating which ones they need to go in and things like that. We're just saying, take the matrix, flip the matrix, merge the matrix, right? And I think thinking in those higher level terms if you can, if your application can afford the performance of doing that, and you can afford like bringing in the extra dependency and all of these other things, I think that the higher level way of thinking about things is the better way to do it. You know, if you have the performance considerations and this doesn't match them, if you have low space considerations or something and this doesn't match them, then you have to take different approaches. But I do like the fact that we can just do kind of this high level, look at the matrices, flip them, and then deal with it. Okay, so for part 2, we just need to loop. So let mute small matrix equals I don't know, whatever. Loop here. Well, we don't need a loop, actually, do we? This can be, what should this be? Folds dot fold, right? I guess we don't want fold here, we want reduce, right? And then we put dots here. And then our function takes dots and the operation, and we just return the match of the operation and that is our thing. Yeah, I think it's easier to see what's going on with the matrix approach if you learn to read the library a bit, and splitting a B tree map B tree set isn't easy in my opinion. What do you want to do? A many flips. Yeah, totally agree with that. Totally agree. What do I want to do? I want to set up this fold. So we have a set of, we have a vec of folds, right? So what I want to do is I want to start out with reduce, and I want to initialize our reduce function with the dots. Oh, I don't want fold actually. I don't want to reduce. I want fold. Now that I think about it, I want to initialize our fold with dots. So we're going to iterate over all of the fold operations. We're going to initialize with an empty matrix or whatever, our initial matrix. And then in our accumulator, which is going to be the matrix, we're going to take each operation, we're going to apply each operation, and then we're going to return that as the next one to deal with. It's also much harder to do part 2 without a matrix, in my opinion, since it's wholly dependent on printing it in a uniform pattern. Why not 4 next? We could do 4 next. There's nothing wrong with 4 next. The method folds is this on the struct. Do we need to iter? There we go. And now we have to put the dereferences back. There you go. Don't solve ending issues before you solve beginning issues. Oh, that's part 1. What's the score for part 2 that we're supposed to have? We don't even have... It doesn't even tell us, does it? So we don't even have a test. So, oh well. We are not going to do folds.iter here. We're going to do folds.iter here. So why not for next? Basically, not for next, because the way that I'm thinking about this problem is that we have a vec of fold operations, right? So we have a list of fold operations that we need to accomplish. And what we need to do is have each of them in turn operate on a specific piece of state. And what fold does is it takes a list of operations and allows us to apply them one by one to a piece of state. So when I say that I'm folding on this thing, we're building up that matrix, and there's no room for like, we're doing other things, we're not doing side effects, which like, okay, so Rust helps us a lot with the mutability aspect of doing different kinds of side effects like that. And there's nothing wrong with doing the for in kind of loop over this and keeping like let small matrix equals like a mutable matrix that we then keep modifying. Nothing really wrong with that. But fold says something about our program that for each doesn't, right? Fold says we're taking a list of things and we're combining them all, we're reducing them all into a single thing. So anytime you see fold or anytime you see reduce, that's what's happening. And if you start thinking a little bit more in data structures, we're turning many data structures into a single different data structure. And that's why I used fold. Producer dimension mismatch is not good. So let's do dot rows. We'll do a for loop here just for kicks. We're going to print line this row dot iter dot map point, and then we're going to bring this in, and this is going to be x, this is going to be dot. So what's the problem here? Dot map dot collect into string. Which obviously fails. So we need to figure out why our producer dimension is mismatching. Expected 447655 got 446655. So one of these is barely wrong. I'm going to put debug on fold so that we can print it out. Do derive debug. So we fail on the second fold. I wonder if we should do Why do we have 447? So let's do small here, and then debug small dot shape. So we end up with 894 by 655. Interesting question though. If we fold again, if we fold twice, right, then we get an even number, right? No matter what. So our puzzle input, if we scroll all the way down and look at the folds, this is fold along x equals 40. I wonder if there's an even odd thing. Is the solution matrix rewritten in dots? I think so, right? Like this? Where was I? Here. So we end up folding along even numbers down here. We fold along 447 here. Four 47 times 2 is 894. So what I think we're doing here maybe is we're getting the length of the axes, right? And we're doing it over 2. And that's giving us, in this case, probably 446, right? I think that this math here is what's getting us. Got 446. Why did we get 446? Because we need to do it inclusive, maybe? So we do here from 0 to num axis 0, right? Num axis 0 is 446. In that case, because it's even, we do need to do it inclusive, right? But that doesn't affect the off by 1 issue here. This seems like the off by 1 issue here. When we're slicing, so num axis 0 is 447. But 447 is exactly where we need to be, so we don't remove a line. I think that's the issue. This is automatically removing lines. And we shouldn't be removing a line. So we need to determine whether this is even or odd. Or Yeah, I think we just need to do the determination whether this is even or not. Equals num axis 0. No, it's axis 0 len mod 2 equals 0, right? So if it's even, match this axis. Making this the skip amount. This is going to go here. And then we should get through that one. Yes. Let's add this logic to the other one as well, because I feel like even if we don't use it, we should have the same logic in both places, which makes me think that these should actually be a function that we pass arguments into, but I didn't do it that way, so we'll live with it for the moment. Isn't there a mod operator? You can add instead of the one result from x mod 2. Yes, I think you're right. Because it's, yeah, because it's only going to be 0 or 1, right? Now the question is, can I read whatever this is? This is the real reading comprehension test. Maybe if I make it smaller, it'll be easier. Maybe if I print out white space, it'll be easier. Let's do some white space. Oh, man. Yeah, I think you're right, Commander. I think you're absolutely right with the skip amount being exactly the amount that you need. I don't know how to read this. What are we at? Like H G A 2 K P whatever that is. It looks like it might be slightly off. Then use it. So I mean, like, we can use it, right? But also it's hard to read, right? Like, why are we doing this here if I put it like that? So let's do axis 1 len mod 2, right? Like that. Because like the test here is whether it's even or not. It's not the mod of the number that we really care about. It just happens to be, right? Like this just happens to be the correct value. But that doesn't mean it's the thing we should have here. This is what I'm doing, by the way, writing OCR code. OCR code? Good luck. Because I don't know that. Try to print it again with marked as dot. Oh my God. I'm trying to blur it to the point at which I can read it. Can y'all read it? Do I need to make it bigger or smaller for y'all? I'm gonna go with H G A 2 Z 2. Is it all characters? 8 capital letters. Okay. G A. It's got to be Z. Got to be K. Got to be P. Got to be R. So the question is, what is this? That's got to be a C then. Can you send me your input? That's not the right answer. This is the worst part of Adventive Code, honestly. It has not to be a real word. It doesn't have to be a real word. Yeah. I feel like some of these are in the wrong spots, maybe. So first time seeing this, but I think I had the same input as you, Chris, because I saw the same messy output earlier today. You saw exactly this, is what you're saying? Like the dots, Ben? Are these the letters you came up with? Because I can't read this. You want me to copy paste the input to you, Mickey? I can do that. Done. I used for printing dot and 9 with 9 in red. So you did like dot for the regular things and 9 for the non. I mean, the 9s are unmarked, so whatever. What are those boxes? UTF 8 box. One of these, maybe. That looks more bad. Yeah, it didn't really help, did it? maybe it looked better with the red that you had earlier. Full block. That's what I wanted. There we go. Okay, so what letter looks like that? So I think we are at H C G A Z K P R. Is it PR or FR or what is that? That looks wrong though, right? Like it looks like I messed up the output right here. Or maybe there's just not. My solution works. Can you give me your input? HEC E? That's an E? Oh. RZKPR. RZKP. That is a P. R. That's supposed to be an R? Yeah, there is a wrong dot there for sure. Interested in why there's a wrong dot there. HC Gaz PR. HC Gaz KPR. HEC 1 2 3 4 1 2 3 4 5 6 7 8 HEC HEC RZKPR. So that's the right thing. I'm a little concerned that we have the extra dot here. Right? But most of the letters look right. I'm wondering, do you get a different output, Nikki? Like, do you get dots in different places and stuff? Because I think, Commander, you were saying you got... Can I share my input? Yes, I'll adjust it. Yes, happy to. Let me... What is this? Day 12? Day 13? Day 13. Public gist. This is the gist. I think I can paste. Yes. Can y'all see that link? You'll shoot me a JPEG of my input. Cool. that is not my input, Nikki. Somewhat hilariously. Yeah, that's your exact input. So did you get different output then, Ben? Did you get more readable output? Like, I'm wondering if I did something wrong for one of the transformations. Yes, I definitely did something wrong for one of the transformations. So, interesting. What am I doing wrong then? The worst part about this is that it's mostly right. There's no way to test, right? I guess if we do part 1, but we apply part 2, that could work. Like if instead of doing, let's see, where's process part 2? If we go to the bin, right, and we change the input file to be test input, and we run part 2, no such file or directory. Of course, of course. So it's in source. Is that where I put test input? Why did I put it in source? I don't know. Oh, right, because it's next to lib. So if we do this, we get 0, which is what we should have gotten. So yeah, I don't know. I'm gonna have to go discover the test case for creating the letters or something, and then go back and figure out what's going on here. Because the test example works, but the part 2 comes out mangled. And I don't think there's anything else that they give me that'll help me. So we could do this. We could do something interesting maybe. For row in small dot rows. Yeah, I mean, it doesn't even look like anything until the end. Right. We need this in both places anyway. Oh, you know, a small equals this small for using the matrix might be helpful here. I got that messy output with my initial algorithm. I did clean the cone up and got it to be clear letters. Interesting. Very interesting. We do have our final output here, right? This little whatever you want to call it. Bring this over here for a sec and just this is going to be hard to debug on stream. So I almost think that I'm not going to debug it on stream, and I'll debug it in the Advent of Code channel in Discord if I have time to do it later today. Because this should work, right? To get it to print your way so your brain can see the letters was the hardest part of part 2 for me. Yes, that was definitely hard for me. But I think actually that this output, for whatever reason, might not be correct. I have no way of knowing what the final output is supposed to be because it's not even telling me. And doing this one works. So I'm going to have to build up my own test case to figure out why this is failing. Well, technically it's not failing, but Like I'm gonna have to. I don't even know how to step through all of these to figure this out. Because I don't even know where the problem is, and I don't have any of the steps in between. So like, I'm basically, if I'm gonna fix this, I'm gonna have to just stare at this as hard as I can stare at this, I guess. Heck, RZ, KPR, yes, that was the answer. Don't know where to step to debug. Yeah, that was me a few days ago. Well, I mean, like, I have all of the I have all of the steps, right? But I don't know what it's supposed to be. And I don't have any of the steps that it's supposed to be. So I have to just stare at the algorithm and see if I find something. Because the initial one works. If we do part one, if we do the test input passes. Right? Like the test input gives us exactly what we're supposed to get. So h equals 3 with. One, two, three, four. It's 4 wide for me. Between every character and empty column, yes, that is also true. When does that get stuck in there? One of these two, right? So it's got to be this one on the bottom here. So maybe I work myself backwards like that, and I figure out this is going to be ridiculous. Yeah. Okay. I'm not going to debug that on stream because it looks awful, and it's just going to be a lot of me staring at the code instead of actually doing anything. I don't get what the issue is. Maybe we're slicing in the wrong spots now. Like slightly the wrong spots. Throwing out the wrong rows, maybe. Yes, all with 4 with an empty column between them. That is what I got. H is supposed to be with 3 is what you're saying? H for me is 4 wide. For sure. Four, 8, 12, 16, 20, 24, 28, 32, 3, 4, 5, 6, 7, 8, 9, 39, and then maybe one on the end, 40. So we end up with 40 columns. 8 characters. It's got to be something as simple as, okay, I'm getting nerd sniped by doing this. Anyway, it's got to be something as simple as choosing the wrong starting column or something on one of these. So maybe I'll figure that out and maybe I won't. Like this just totally bugs out, right? If I just break this, like we get panics. So those are wrong, for sure wrong. Yeah, don't know. I'm not really doing much math here. So like I'm not really doing anything except for selecting the areas of the matrix that we're supposed to select. So I must be selecting something wrong. But in any case, we got everything working. Let's run, I don't know, let's run dat for kicks maybe. I don't necessarily think that this is instructive. 6 megabytes and probably far less, 2 megabytes. I skipped every line that is folded. Yeah, I skipped them too. So cargo bench maybe, just to show the numbers on stream. Again, I said like the heap allocations are going to be higher for this approach because we build out the entire array, I believe. Yikes, I didn't get rid of the debugs. Let's just kill that. That doesn't look fun. All right, that's it for me for today. The problems work. I am going to commit this. Day 13. Day 13 is up on GitHub. I'll drop a link to the repo. Some people were saying they wanted to see it. Here's day 13 if you want to see it. And I'll be back tomorrow, again, 10 a.m. To do day 14. And I don't know if I figure out what I did wrong in the matrix sometime later today, if it pops into my head or whatnot, then I'll explain it on stream tomorrow morning. Later, y'all.